Okay, so our order of rotational symmetry is the amount of times that I could rotate that shape, like we saw, to get it to look like itself again, between 0 and 360 degrees around. So for this particular shape, we got to figure out, okay, how many times was that? Well, I rotated it once. Where was it? About there. There's one time. There's 2 times. There's 3 times. Not quite. Not quite. There's 4 times. And then back to 360, that's 5 times. So I could rotate this shape 5 times, and it would land on top of itself before getting back to 360. And notice how this star has 5 points on it. So there is a correlation there between the amount of things coming off of a shape and the number of times that you can rotate it, which is called the order of rotational symmetry. So starting with notes here. It's going to be very short notes today. Rotational symmetry. Okay, and this is in the way. The order is just the number of times. This is called mapping a shape onto itself when you rotate it and it lands back as what it looked like originally. So number of times you can map a shape onto itself by rotating between 0 and 360 degrees. Okay, so for example, we had the star. The order was 5 because I could rotate that thing 5 times and have it land on top of itself each time between 0 and 360. So the order was 5 for the star, and notice how it had 5 points. What do we think the order would be for a square? Any guesses for the square? Yeah, Christy, you got it. It's 4. It's got these 4 corners, all the sides are the same length. The order is 4. But what about like a rectangle? Would that have like a lesser degree or lesser order of rotational symmetry? Yeah, Owen's got it. It's 2. And the reason being, if I rotate the rectangle like that, all of a sudden it's sideways. It's not up and down anymore. So I have to rotate it all the way around to get it to look like it originally did. So that's our difference with rectangles here. The order of rotational symmetry for a rectangle is 2. Okay. Do another one. What about something like that? Well, it has 2 things coming off of it, right? And those 2 things look the same. So the order would also be 2. assuming these were all the same size and length and shape and everything, because, drawing is hard, this would have an order of 4. What about this shape? This is one that does not have any rotational symmetry, because some shapes just don't, and that's okay. So this one has no rotational symmetry. Okay. So order is one of the things. Yeah, it would be kind of like having an order of 1, which everything has an order of rotational symmetry of at least 1. Because anything, if you turn it 360 degrees, it's going to land on top of itself again. So that's an order of 1 is also considered no rotational symmetry. So yeah, that's the right idea, Owen. So order is one of the things we care about. The other thing we care about is called magnitude. And magnitude is the number of degrees that you have to rotate it each time to get it to land on itself. So that's the minimum number of degrees you have to rotate the shape to get it to land, to map onto itself. So for example, if we go back to our star, the first time I rotated it, I had to go, it was 72 degrees. Come on, 72. Play nicely. Well, we're going to get as close as we can here. To get it to land on top of itself was 72 degrees the first time, then 72 degrees more, 72 degrees more, 72 degrees more. The way that you find this number, it's 360 degrees divided by the order. So the magnitude is 360 degrees divided by the order. So in this case, it was 360 degrees divided by 5, which was 72. For this one, it was 360 divided by 4 then, which is 90. So for a square, each time I rotate it 90, it would map on top of itself. For the rectangle, 360 divided by 2, which is 180. Same thing with this one. And then this one is similar to the square, where we've got magnitude is 360 divided by 4, which is 90. And then this one with no rotational symmetry, we don't have to worry about magnitude. Okay. So that's rotational symmetry. That's everything we need to know about rotational symmetry. So the rest of today is going to be spent kind of reviewing here and getting some time reviewing all of our different transformations and also our different types of symmetry. So to help us review, we are going to do a Kahoot. So go ahead and open a window for Kahoot. If you want to do it on your Chromebook or your cell phone, feel free. If your Chromebook doesn't work at the same time as like a Google Meet and a Kahoot, I will post an alternative that you can do as well.